Ever wondered how you can control a powerful light with a tiny switch? Or how your car's horn blasts when you just tap a button? The secret lies in a seemingly simple, yet incredibly versatile device called a relay. But what exactly is a relay? That's what we're diving into today. We're going to break it down in simple terms, so even if you've never heard of a relay before, you'll understand exactly how it works by the end of this video. Think about it. You flip a light switch, and boom, the room is illuminated. But the tiny switch itself isn't handling all that electricity. That's where the relay comes in. It acts like a middleman, a messenger between your small control, the switch, and the big power, the light. So, what is a relay in simple words? A relay is essentially an electrically operated switch. It uses a small electrical current to control a much larger electrical current. Imagine it like a tiny gatekeeper that controls a massive floodgate. A small signal opens the gate, allowing a huge surge of water to pass through. Similarly, a small electrical signal activates the relay, allowing a large current to flow through, powering your light, your car horn, or any other electrical device. Now, let's break down the anatomy of a relay. Inside, you'll find a few key components. First, there's the coil. This is a wire wrapped around a core, usually made of iron. When a small electrical current flows through this coil, it creates a magnetic field. Think of it like a tiny electromagnet turning on and off. Next, we have the contacts. These are the parts of the relay that actually make or break the electrical connection. There are two main types of contacts, normally open, NO, and normally closed, NC. Normally open contacts are, as the name suggests, open when the relay is not activated. The circuit is broken, and no current can flow. Normally closed contacts, on the other hand, are closed when the relay is not activated, allowing current to flow. Now, let's put it all together. Imagine you want to turn on a light with a small switch. You connect the switch to the coil of the relay. When you flip the switch, a small current flows through the coil, creating a magnetic field. This magnetic field attracts a small metal arm, called the armature, which is connected to the contacts. If we're dealing with normally open contacts, the magnetic field pulls the armature, closing the contacts. This completes the circuit for the light, allowing a large current to flow and turn it on. When you flip the switch off, the current to the coil stops, the magnetic field collapses, and a spring pulls the armature back, opening the contacts and turning the light off. With normally closed contacts, the opposite happens. When the relay is not activated, the contacts are closed, and the light might be on. When you activate the relay, the magnetic field pulls the armature, opening the contacts and turning the light off. This might seem counterintuitive, but it's incredibly useful in certain applications, like safety circuits where you want something to be on by default and turn off when a fault is detected. So, why are relays so useful? Well, they offer several key advantages. First, they allow you to control a high-power circuit with a low-power circuit. Think about your car starter. The tiny key you turn doesn't directly send the massive current needed to crank the engine. It activates a relay, which then handles the heavy lifting. Second, relays provide electrical isolation. The low-power control circuit is completely isolated from the high-power circuit. This protects the control circuit from voltage spikes or other electrical disturbances in the high-power circuit. It's like having a buffer between the delicate electronics of your control system and the potentially dangerous high voltage of the device you're controlling. Third, relays can be used for logic operations. You can combine multiple relays to create complex circuits that perform logical functions like and, or, and not. This is the foundation of many automated systems. Fourth, relays are reliable and durable. They can withstand harsh environments and can switch on and off millions of times without failing. This makes them ideal for use in industrial applications and other demanding environments. Relays come in all shapes and sizes, from tiny relays used in electronics to massive contactors used in industrial power systems. They can handle a wide range of voltages and currents, making them incredibly versatile. You'll find them in everything from your household appliances to your car, to industrial control systems. Now, let's think about some real-world examples. In your car, relays control everything from the headlights and the horn to the starter motor and the fuel pump. In your home, they might be used in your air conditioning system, your washing machine, and even your doorbell. In industrial settings, relays are used to control motors, valves, and other high-power equipment. Relays are also essential in telecommunications. They're used in telephone exchanges and other communication equipment to switch signals and route calls. They're also used in alarm systems to trigger sirens and other alerts. The applications of relays are virtually endless. They are a fundamental building block of electrical and electronic systems, and they play a crucial role in our modern world. From the smallest electronic gadget to the largest industrial machine, chances are a relay is involved somewhere. So, the next time you flip a switch, honk your horn, or turn on a light, remember the humble relay. It's the unsung hero of the electrical world, quietly working behind the scenes to make our lives easier. It's a simple device with a powerful impact. With that said, thanks for watching, and until next time.